Welcome. In this video, we will be taking a look at section 10B. Before we do that, I want to draw your attention to our course page and taking a look at one resource that should be helpful for you guys. There is a trigonometrics formula document in our chapter 8 notes here that you guys can click on. These are going to be all the formulas that are available for you guys for the trigonometric or the trigonometry midterm that will be coming up in a couple weeks. So you're going to have your reciprocal identities, your sum and difference identities, quotient, Pythagorean theorem, product to sum, negative angles or the even odd functions, along with a bunch of other identities that we're going to be using in the next couple sections. So just know that you have these formulas available to you guys, and you don't have to memorize these, but you do have to understand how to use them and when to use them. So let's take a look at section 10B together. We'll do an introduction with this. So in this section, we'll be taking a look at the sum and difference identities. So we have the sum and difference identities for cosine, sine, and tangent. Notice that we'll have just a combination of cosines and sines for these two angles A and B that we are either adding together or subtracting from one another. We also have the cofunction identities. So sine and cosine are cofunctions with each other, meaning that sine of 90 minus x is equal to the cosine of x. And just as an example, we know that sine of 60 degrees is the same thing as cosine of 30 degrees. Both of these are equal to root 3 over 2. That's just one example of that cofunction property. Cotangent and tangent are going to be cofunctions, and cosecant and secant will be cofunctions. So keep those in mind as more identities that we can work with. Other ways we can rewrite these identities are with our radian calculations. Pi over 2 is 90 degrees in radians. So just recognize that those are the same formulas, but just represented in radians instead of degrees. So let's consider some half angles first, or the sum and differences we'll do first here in example 1. So in example 1, we are going to go find the sine of 15 degrees. So the sine of 15 degrees, if I wanted to express that exactly, one way I could do that is with difference of sine of 45 degrees. That's a known angle to us in the unit circle, minus 30 degrees. So 45 minus 30 is 15. So if I can solve this expression that I've just written, I can solve the sine of 15 degrees. So notice that we really have the form here, sine of A minus B, where A is 45 degrees and B is 30 degrees. So we can take a look at using the difference identity for the sine function. So that's written up here in our table, where A again is 45 and B is equal to 30. So we can rewrite this with our identity, and I'll highlight the one we're using up top here, the sine identity for difference, where A is 45, cosine or the B angle is 30. So let's rewrite this expression. This is going to be the sine of A, which is 45, cosine of B, which is 30, minus the cosine of A, which is 45. And then we have the sine of b, which is 30. All right, now all I need to know is these acute angles for sine and cosine. So let's start left to right and fill in these side ratios that are equivalent to each of these trig functions. First, we'll have the sine of 45. The sine of 45 will just be root 2 over 2. The cosine of 30, we know that to be square root 3 over 2. And then we're going to subtract. The cosine of 45 is also square root 2 over 2. And then the sine of 30, we can rewrite as 1/2. That's the side ratio for sine of 30. And to finish it off, we'll just want to combine like terms. Looks like we'll have a product in both of these two places. So we'll have the square root of 6 in the numerator over 4 minus the square root of 2 over 4, which we can express as the square root of 6 minus the square root of 2 all over 4. And we'll just leave it here in the exact form. And that would be our final expression for this sine of 15 degrees. So in the next couple examples, we'll work through a few more of these examples using the sum and difference identities.